Hello, dear student. In previous class, I discussed about the oxidation number. What is oxidation number? The oxidation number of an atom in a compound is the number of electrons that appears to have been lost or gained during the formation of that compound. Oxidation number may be positive, zero, negative, or fraction or fraction. There are different rules for the calculation of oxidation number. These are the rules for the calculation of number of these are the rules for the calculation of oxidation number. I have given some example also for the calculation of the oxidation number. But in this class, in today class, I will explain also a new topic, that is your writing the name of compound. How you will write the name of a compound. Look at that. Read some rules and regulations for writing the name of a compound. There are generally two types of names are used for a chemical compounds. One is said to be common name, that is your said to be trivial name. It is said to be what? You can say that is your or common name, or that is your said to be trivial name. You can say that trivial name or common name. There are different compounds which having particular common name, that is your trivial name. For example, if you think about sodium hydroxide, this is the chemical name, but it is also called as caustic soda. So here the common name of sodium hydroxide is your caustic soda. Remember this. Next is the potassium hydroxide. This is called caustic potash. Remember these two. Your sodium hydroxide is called caustic soda and potassium hydroxide is called caustic potash. Both are having nearly same common name. One is caustic soda, another is caustic potash. Next is CaCO3, calcium carbonate. This is called calcium carbonate. The chemical name is calcium carbonate, but it have also a common name, that is your limestone. Limestone is the common name, but calcium carbonate is the chemical name of CaCO3. Next, another is the quicklime, which having the formula that is your CaO, and it is having the chemical name that is your calcium oxide. Next is bonus. Bonus having formula Ca3PO4 twice. Its chemical name is your calcium phosphate. Next is the dry ice. It is very famous. Everybody can know about this. Carbon dioxide. That is your said to be dry ice. Actually, its chemical name is your carbon dioxide. So, a few chemical names, a few compounds which having particular common name. It is your duty to remember this common name by repeating practice. Next, another move to the other point in electrovalent compound. If you will think about the electrovalent compound, in electrovalent compound, the electropositive ion is named first, then the electronegative ions. If I want to explain this point, this law, then what will be the explanation? Let me explain. Suppose you take sodium chloride. This is a electrovalent compound. Here the bond is present, that is your electrovalent bond, that is your ionic bond is present in between sodium and chlorine. So this is called electrovalent compound. Electrovalent compound means the compound which is formed by the ionic bond. Ionic bond. That is, if the compound is formed by the ionic bond, then that is your said to be electrovalent bond. There are many examples of electrovalent compound, that is your NaCl, Ni, MgS, KBr, KCl, like that. You can think many electrovalent compound. If you want to see the electrovalent compound, then remember in electrovalent compound there are two radicals are present, opposite radicals are present, that is your say commonly said to ions. One is the positive ion, that is your said to be electropositive ions or electropositive radicals. Another is the negative ions, that is your electronegative ions or electronegative radicals. In NaCl, what will happen? The sodium carry the Na plus ion and Cl carry the Cl minus ion. So here Na plus ion is the electropositive ion, but here Cl minus is called electronegative ion, that is your electronegative radicals. If you want to write the electrovalent compound, that is your ionic compound, then there is a certain rule regulation for naming. During the naming, remember the electropositive ion, the name of the electropositive ion is named first, then the electronegative ion. That means in the name of the electrovalent compound, ionic compound, the electropositive ion is named first, then the electronegative ions. Here, Na plus ion is the electropositive, Cl minus ion is the electronegative ions. So here, during naming the NaCl compound, remember write down the name of sodium first. That means what is the name? That is your sodium. This is electropositive ion. It is written first. Then the electronegative, that is your chlorine. So here I can write chloride. That means the name of NaCl is your what? Sodium chloride. Similarly, think about NaI. If you think about sodium NaI, here Na is the electropositive ion. So here I have written first, that is your sodium. I is the electronegative ions. So I have written iodide. Iodide for I as a electronegative ions. Similarly, you can think about magnesium sulfide. Here, magnesium sulfide means that is your magnesium is electropositive ion, sulfur is the electronegative ion. So, magnesium name is named first, then the sulfide name. That means the name of MgS is your magnesium sulfide. You will take another example also, MgSO4. Here we can write MgSO4. If you think about the MgSO4, here magnesium is the that is your electropositive ion that carries Mg2 plus ion. Here sulfate SO4 2 minus, that is your electronegative ion. So here magnesium name is named first, then the sulfate. So the name of MgSO4 is your what? Magnesium sulfate. Magnesium sulfate. So remember, for naming an ionic compound, the electropositive ion is named first, then the electronegative ions. Next, there are different types of compounds which are ended with the word os and another is your ek. The suffix ox is generally used for the lower oxidation state, and the suffix ek is named for the higher oxidation state. Let me explain. Suppose think about two compounds. Suppose think about FeO. Another is your suppose take Fe2O3. The iron here, the iron having the oxidation number is your how much? That is your plus 2. But here the iron having the oxidation number is your plus 3. I already discussed in the previous class how can you calculate the oxidation number by using different rules. Here the oxygen having the fixed oxidation number, that is your minus 2. So for balancing, here the iron having plus 2 oxidation state. Similarly, in Fe2O3, the oxidation number of iron is your that is your plus 3. You can also verify by applying the rules regulation for the calculation of the oxidation number, which is already discussed in the previous class. But remember, if you want to think about the name of FeO and Fe2O3, here iron in FeO, iron carry positive plus 2, but in Fe2O3, iron carry plus 3. Here the lower oxidation state of iron is found in the FeO. In FeO, iron having the lowest oxidation state, that is oxidation number, that is 2. But in Fe2O3, iron having higher oxidation state, that is 3. So remember, for naming the FeO, it is necessary, it is compulsory to use the word os. That means you think about the ferrous. You think about the ferrous. Next, for Fe2O3, you generally use the eke word. The eke, that is your, you can think about ferric. Now, then what will be the name of this compound? FeO means ferrous oxide. Next, Fe2O3 means ferric oxide. One is ferrous oxide, another is ferric oxide. From this example, it is clear that the compound which carry the lower oxidation state goes to os, and higher oxidation state goes to eke. Similarly, you can think about FeCl3, FeCl2. In FeCl3, iron carries plus 3 oxidation state, but in FeCl2, iron carry plus 2 oxidation state. So plus 2 is the lowest, so your ferrous is used, that is your ferrous chloride. But if you think about FeCl3, that is your, in FeCl3, Fe carry plus 3 oxidation state, which is higher than the plus 2 oxidation state. So the name starts with eke. So here we can say that FeCl3 means ferric chloride. Similarly, you think about the plumbous plumbic. If you will think about PbCl2, in PbCl2, lead, that is your Pb carry plus 2 oxidation state. But if you think about PbCl4, then Pb carry plus 4 oxidation state. Among plus 2 and plus 4 oxidation state, plus 2 is the lowest oxidation state. So its name is so in this, the name of this compound, you must use os word. Next, for naming the PbCl4, you generally use eke word. Now look at that. Here PbCl2 means plumbous chloride. Here PbClO4 means plumbic chloride. Similarly, you think about the CuCl. If you think about the CuCl, here copper carry plus 1 oxidation state. But if you think about CuCl2, here copper carry plus 2 oxidation state. Here plus 1, CuCl having the lowest oxidation state, that is your plus 1. But CuCl2, in CCuL2, copper carry plus 2 oxidation state, that is your higher oxidation state. So for CuCl, it is necessary to use os, and for CuCl2, it is necessary to use eke. So the name of CuCl is your what? Cuprous chloride. Cuprous chloride. The name of CuCl2 means cupric chloride. That is your cupric chloride. One is cuprous chloride, another is your cuprous chloride. Cuprous. Next, move to the next rule for binary compound. For binary compound, you generally use mono for 1, di for 2, tri for 3. For 4, you can use tetra. For 4, you can use tetra. For 5, you can use penta. Like that, you can use the that is your words which is used as a prefix. Look at that. If you think about CO and CO2, your one oxygen atom is present, so here it is said to be monoxide. Your two oxygen atom is present, so it is said to be dioxide. Totally, we can say that CO means carbon monoxide. Here mono is used to indicate there are only one oxygen atom. If you think about CO2, that is your said to be carbon dioxide. Your di is used for two oxygen. So your CO means carbon monoxide, CO2 means carbon dioxide. Like that, you can think about SO2 and SO3. Here, two oxygen atom is present, so here you can say that sulfur dioxide. Next, for SO3, you can use sulfur trioxide. Like that, you can also think about NO2, NO3. Your two oxygen atom is used. That is also di is used. That means your nitrogen dioxide. Your three oxygen is used. So here you can say that nitrogen trioxide. You use such type of word, that is your for one mono, two for di, three for tri, four for tetra, five for penta. Next thing about some binary acids are named by adding the prefix hydro for hydrogen and suffix ek to the root name of the second element. Look at that. If you think about HF, HF means that is your hydrogen fluoride. The binary compound name is your hydrogen fluoride. But if you will think about the acid name of HF, acid means aqueous solution of HF. This is the difference. HF means hydrogen fluoride, but aqueous HF means that is your said to be hydrofluoric acid. Similarly, HCl is the hydrogen chloride, but if you add water, that converted into aqueous HCl, that is called hydrochloric acid. Similarly, HBr means hydrogen bromide, but for acid name it is said to be hydrobromic acid. Similarly, Hi hydrogen iodide. Next it is said to be hydroiodic acid. For H2S, that is your hydrogen sulfide. Here you can say that hydrosulfuric acid. Next is your H2SC, that is your hydrogen selenide, hydroselenic acid. Similarly, H2T, that is your hydrogen telluride, that is your said to be hydrotelluric acid. Next is Hessian hydrogen cyanide, that is your hydrocyanic acid. Difference is for HF you can say that hydrogen fluoride, or aqueous HF that is said to be hydrofluoric acid. For naming the acid name, generally you use two word, that is your hydro, another is your ec. Look at that. Your hydro is used for hydrogen, and ek is used with the root name of the second element. Root name of the second element. Here the second element is fluorine, and its root name is your fluorine. FLUOR. This is your fluorine. Then in the root name you use ek. That is your said to be. That is your said to be what? Fluoric. That is your said to be fluoric acid. So remember, for naming the simple binary acid, the binary acids are named by adding the prefix hydro. Look at that. This is your hydro. Here also hydro. This hydro. This hydro. Uh, that is used for hydrogen, and the rest is your for HF. The rest is your fluorine. So the root name is your fluorine. Use the suffix ek. So here we can say that fluoric acid. So totally we can say that HF means hydrofluoric acid. Like that you can also understood what is the meaning of this rule. Next, move to the oxy acids. Nomenclature of oxy acids. Here I have given few example of oxy acids. If you think about the oxy acids, in case of HCl, the chlorine atom carry the oxidation number +1. In case of HClO2, the oxidation number of chlorine is your +3. In case of HClO3, the oxidation number of chlorine is your +5. In case of HClO4, the oxidation number of chlorine is your +7. Generally, we used in the previous, in the recently I have discussed about the OS and EEC. Here I have discussed about the OS and EEC. Instead of the two word, that is your os and ek, there are also another words are used, that is your hypo. Next is your por. You can use the os ek word. There are different words used os, eek, hypo, por, like that. So actually, if you will think about the order of what I can say that is your used for naming. Here I can say that hypo. Hypo is used for the lowest oxidation number. This is your lowest oxidation number, and eek is used. Sorry, por is used for oxidation, highest highest oxidation for. Look at that. If I have a plus 1, plus 3, plus 5, plus 7. Here plus 1 is the lowest oxidation state, plus 7 is the highest oxidation state. For these oxyacids, for these oxyacids, we can say that plus 1, plus 3, plus 5, plus 7. Here plus 1 is the lowest, plus 7 is the highest. So for plus 1, that is your lowest, you can say that hypo. You use the word hypo. For highest, you used the por. And again, you think about the os. This is your os, this is your eek, because os and eek, from os and eek is used for higher. So actually, the order you can say that is your hypo greater than os greater than eek greater than por. Look at that. In HClO, in HCl, the oxidation number of chlorine is your plus 1, that is the lowest. So here I can use hypochlorous acid. The name of HClO is your said to be hypochlorous acid. But if you think about HClO4, here the oxidation number of chlorine is the highest, that is your plus 7. So here I can use the word por. Porchloric acid. The name is just said to be porchloric acid. Now move to the os and eek. In case of HClO2, the chlorine having plus 3 oxidation state. In case of HClO3, the chlorine having plus 5 oxidation state. Among plus 3 and plus 5 oxidation state, plus 3 is the lowest. So os is used, and for plus 5, eek is used. So HClO2 is said to be chlorous acid. HClO3, that is said to be chloric acid. Again, I will repeat here. HClO is named as hypochlorous acid. HClO2 is named as chlorous acid. HClO3 is named as chloric acid. HClO4 is named as perchloric acid. These are some rules and regulation for writing the name of a generally compound. Next, I will move to the another topic, that is stoichiometry calculation. Actually, what is stoichiometry calculation? Stoichiometry calculation gives a quantitative relationship between among the reactant and product in a chemical reaction. For a balanced chemical reaction, we generally use the stoichiometry calculation. Look at that. Suppose I will think about a reaction. Nitrogen, that is your react with the nitrogen react with the hydrogen gives ammonia. This is the reaction. Nitrogen react with the hydrogen gives ammonia. If you balance, then you will find like this: N2 plus 3H2 gives 2NH3. This is the balanced chemical equation. This is what balanced chemical equation. Again, I will say that for this reaction, the balanced chemical equation is your N2 plus 3H2 gives 2NH3. Then, if I want to think about the stoichiometry calculation, then we can express it in different way. You can express it in molecule, in Avogadro's number, in mole, in mass, in volume. Any term you can relate it to each other, to the product and the reactants. You can make a relationship between the reactants, make a relationship between reactant and products by using different terms. Look at me. Since here one nitro N2 molecule is used, so in if I want to explain this equation in terms of molecule, here I can say that one molecule of nitrogen react with how many molecules of hydrogen? 3 molecules of hydrogen. How I can how it is how why here 3 is used? Because here in the coefficient in the equation, the coefficient for hydrogen is your 3. So here I have written that is your 3 molecules. But if you think about the ammonia, here 2 is written. This can be found by balancing the chemical equation. So here I can write 2 molecules. That means in terms of molecule, I can express the 1 molecule of N2 react with the 3 molecule of hydrogen gives it 2 molecule of ammonia. Suppose I want to express in the Avogadro's number. Suppose I will explain about the Avogadro's number. I converted this equation. I explained this equation in terms of Avogadro's number. Here, one only one N2 molecule is used. So here I can write 1 into 6 plus 6.022 into 23 molecules. Next, here I can say that 3 into 6.022 into 23 molecules. Next, here I can write 2 into 6.022 into 23 molecules. As per the coefficient, I explained the equation in terms of Avogadro's number. If you want to explain the equation in mole, so here I can say that 1 mole, here we can say that 3 mole, here we can say that 2 mole. Look at me. If you want to express the equation in moles, here only one nitrogen molecule is used. So here I have written 1 mole. Here also, if you think about the hydrogen, here 3 nitrogen is used. So here I can write 3 mole. Here 2. So here I can say that 2 moles. If you want to think about the mass, if you want to explain the equation in terms of mass, then what I will write here, since your nitrogen molecule is one nitrogen molecule is used, so here I can put the molecular mass of nitrogen. Nitrogen having atomic number is your 14. If you think about the molecular mass of nitrogen means 2 into 14, that is your 28. So here I have written, if I want to express the equation in terms of molecular gram molecular masses, here I can write 20 gram. That means 20 gram of nitrogen. Similarly, here 3 H2 is written. We know that if you think about the molecular mass of hydrogen, the molecular mass of hydrogen is your 2, because atomic number of hydrogen is your 1. 2 hydrogen means 2 into 1, that is your 2. So here I have written 3 hydrogen means here 3 hydrogen molecules means 3 into 2, that is your 6. So I have written here 6 gram. 28 gram of nitrogen, 6 gram of hydrogen, and combine with each other to form 2 NH3. That means 2 into molecular mass of ammonia. 2 into molecular mass of NH3. Molecular mass of NH3 means molecular mass of NH3 means what? 1 into 14 plus 3 into that is your 1. So here I can write 14 plus 3, that is your 17. Since 2NH3 is used, so I have written 2 into 17, that is your 34. That means here I have written 34 gram. In terms of mass, I can say that 28 gram of nitrogen combined with 6 gram of hydrogen forms 34 gram of NH3. This is expressed in terms of masses. If you want to express the balanced equation in terms of volume, then here we can say that here 1 NH2, thing means 1 mole. So that is your 20.4 liter. Suppose here we can use 20.4 liter. Then here 3 H2 molecule is used. That means here we can say that 3 into 20.4. If you think about the ammonia, here 2 NH3 is used. So here I can write 2 into 20.4. 3 into 20.4, 22.4 means 67.2 liter. 2 into 22.4 means 44.8 liter. So here I can say that 22.4 liter of nitrogen combined with 67.2 liter of hydrogen forms 44.8 liter of ammonia. This relationship among the reactant and products are said to be stoichiometric relation. You can also think in terms of mole volume, mole mass. You can use in different way also. Here you can say that 1 mole of nitrogen requires 6 gram of hydrogen, produce 34 gram of ammonia. You can cross the relationship. Here we can say that 22.4 liter of nitrogen having 3 moles, 22.4 liter of nitrogen react with 3 mole of hydrogen, form 2 mole of ammonia. You can also cross the relationship. Next, for better understanding, I want to take another example. Look at me. How can you able to write? Take another example. Suppose I have taken a reaction, hydrogen react with the oxygen form water. This is a chemical reaction. If this is a statement, if you want to convert this chemical reaction into chemical equation, here you can say that H2. Here the reactant are hydrogen and oxygen, and the product is your water. So here you can add H2 plus O2. Here you can say that. Sorry. Here you can say that H2 plus O2 gives is your what? Water. Here you can write. If you want to balance, then here you can say that 2H2 plus O2 gives 2H2O. This is the balanced chemical equation. This is said to be a balanced chemical equation. Suppose I want to write that I want to make a relationship between the reactant product in terms of molecule. Then here I can say that in terms of molecule. In terms of molecule, here you can say that two molecule of hydrogen combine with here nothing means one molecule of oxygen, then here two water molecule is used, so here you can say that two molecule of water. Just show the coefficient at first, write down the equation, then balance the equation, and just to show the coefficient, then you can write the express the equation, chemical equation in terms of different parameter, that is your molecule, mole, volume, or mass, like that. Next, suppose I want to express in terms of Avogadro's. Then how can I will write? Here we can write 2 into, here we can write 2 into 6.022 into 10 to the 23 molecules of hydrogen combined with the 1 into 6.022 into 10 to the 23 oxygen forms how much? 2 into 6.022 into 10 to the 23 water molecule. Here we can say that in terms of Avogadro's, in terms of what? In terms of Avogadro's, you can say that 2 into 6.022 into 10 to the 23 of hydrogen combined with 1 into 6.022 into 10 to the 23 form 2 into 6.022 into 10 to the 23. This is the relation in terms of Avogadro's. Next, convert into moles. Then suppose I want to express in moles. Then look at that, here the coefficient is 2. So here I have written, so here I can write 2 moles. Here the coefficient is 1. So here I can write 1 mole. Here the coefficient is 2. So here I can write 2 mole. That means you can say that 2 mole of hydrogen combined with 1 mole of oxygen form 2 mole of water. Next, suppose I want to express in terms of masses. In terms of masses, I can also say that all are present in molecules. So here we used the molecular mass. Here the molecular mass of hydrogen is your how much? 2. So here I can write 2 into 2. That is your 4. 4 gram. Next, if you think about the oxygen, then here you can write oxygen having atomic number, that is your how much? 16. That is your 16. Oxygen molecule means that is your 32. So here I can write 32 gram. Next, water having the molecular mass is your how much? Water. If you think about the water molecule, 2 into 1 plus 1 into 16, that is your 18. So here I can write 2 into 18, that is your 36. So here we can say that 4 gram of hydrogen combined with 32 gram of oxygen form 36 gram of water. If you want to express in terms of volume, if you want to express in terms of volume, look at that. Here 2 hydrogen is used. So here I can write 2 into 22.4, that is your liter. Here I can say that 44.8 liter. Then here one oxygen is used. So here I can only write 22.4 liter. Next here 2 water molecule is used. So here I can write 2 into 22.4 liter. That is your said to be 44.8 liter. Here I can say that 44.8 liter of hydrogen. These relations are said to be stoichiometric relationship. You can express in terms of molecule, Avogadro's numbers, mole, mass. You can take also another example and you will clearly explain in as per your knowledge. That means it is a homework for you. Explain the equation in terms of different way: molecule, Avogadro's number, mole, mass, volume. Suppose I want to give an homework for you. H2 plus Cl2 gives 2HCl. You can do the stoichiometric relation like the two examples. This is a homework for you. For this class, it is very sufficient. Next class, I will discuss about different types of stoichiometric relation. At first, I will discuss about the mole-mole relationship, mass-mass relationship, mass-volume relationship, volume-volume relationship. For this class, this is very sufficient. Thank you for watching the video. Have a nice day.